Jill, you ready to work on our new assignment?
Yeah, let's do it.
Hello guys, how are you? How have things been?
Really well in the lab.
Received an unknown solution of aspirin, and here at the Las Vegas Center of Medicine, it is extremely imperative that the concentration of the solution for the aspirin be around 22%, and we want to ensure that the medicine that we offer our patients is 100% safe and effective. So do you guys have any suggestions for this?
Well, Jill, I think for this assignment that a regular titration just isn't the way to go. Aspirin is an ester, and so it's easily hydrolyzed and broken down to amino acids.
It's important that we keep that in mind, though, because here we want to ensure that our aspirin aids in the aches and pains of our patients without the use of an anesthetic.
Well, I think you're right. A regular titration can bring a lot of error due to the sensitivity of the substance and the quick conversion of aspirin into salicylic acetic acid.
That's true.
Oh, I know. Back titrations! To the lab! To begin, we're going to start off by defining what a back titration is. A back titration is a titration method where the concentration of the analyte is determined by reacting the analyte with a known amount of excess reagent,
Sodium hydroxide,
and then titrating the excess with a second reagent,
hydrochloric acid,
to determine the concentration. Okay, to begin, we gathered all our supplies. We have our ethanol, which is 100% concentrated. We have our Erlenmeyer flask for our analyte. We have our aspirin
And our indicator, phenolphthalein, which will turn from colorless to a pink, and then when we use the hydrochloric acid, it will turn from a pink to a cloudy white. Now we'll begin our titration. First, Taylor will take her 0.3405 gram sample and dump it in her Erlenmeyer flask, along with her stir bar. Now, she will add her 20 milliliters of ethanol. She will now stir that to ensure that all sample has been mixed thoroughly. Next, she will add her phenolphthalein indicator. Now she will begin the titration. Her initial volume is 0.00 milliliters of NaOH. She will continue to add the sodium hydroxide until the solution turns pink. We now see the solution has turned a light pink.
Now, we're going to take our total volume, 5.63 mLs, and account for the ratio. In the reaction, we have aspirin reacting with 2 moles of NaOH. And so we have to account for this in our reaction by placing 2 moles of NaOH consumed for every 1 mole of aspirin. This gives us 11.26 mLs as our volume. We also have to add excess reagent. So we're going to add 10 mLs of excess NaOH, and this gives us a total volume of 21.26 mLs of NaOH.
Taylor will now head over to her beaker to add the excess NaOH.
Since we are at a volume of 5.63 mLs, we are going to make sure we add it so that we have 21.26 mLs. So I'm going to take the volume all the way down to 21.26 mLs.
Now that she has added her excess NaOH, she will now heat the solution for 15 minutes. Now that 15 minutes has passed, she will now cool her solution for 5 minutes in an ice bath.
Now we are ready for part 2 of the titration. We're going to remove the analyte from the ice bath, and we're going to titrate the analyte with the HCl 0.1 molar. She will now add 0.1 molar HCl until the solution turns from a light pink to a cloudy white. The solution has now changed to a cloudy white, and the initial volume of the reading is 0.00 mLs. The final volume reading is
13.07.
A total volume of HCl added was 13.07 mLs. Now we are going to show through the calculations how this makes sense.
reacts with sodium hydroxide to form the acetate ion, salicylic ion, and water. At this point, there is excess sodium hydroxide in solution. Now we must take the reaction back to the true endpoint by performing a back titration. Therefore, we add hydrochloric acid to react with the sodium hydroxide. First, we need to determine the moles of hydrochloric acid needed to equal the moles of sodium hydroxide used. To calculate this, we take the molarity of hydrochloric acid given and the volume of hydrochloric acid that was used, convert it to liters, and multiply them together to get the number of moles of hydrochloric acid, which is equal to the moles of sodium hydroxide since it is a 1-to-1 mole ratio. So 0.1 molar hydrochloric acid times 0.01306 liters of hydrochloric acid, which equals 0.001306 moles of hydrochloric acid, or 0.00136 moles of sodium hydroxide. Now we have to determine how many moles of sodium hydroxide we started with. We are given the molarity of sodium hydroxide to be 0.1 molar, and we determined it took 0.02126 liters of sodium hydroxide to titrate the sample. So 0.1 molar sodium hydroxide times 0.02126 liters equals 0.002126 moles of sodium hydroxide. Next, we need to determine the number of moles of sodium hydroxide that were reacted. We take the moles of sodium hydroxide in excess, 0.001306 moles, and subtract it from the total moles of sodium hydroxide found in the last step, 0.002126 moles. This gives us the total number of moles of sodium hydroxide that actually reacted. In the equation, we saw that for every 1 mole of aspirin, there are 2 moles of sodium hydroxide. Using this mole ratio and multiplying by the number of moles of sodium hydroxide reacted, we determine the moles of aspirin reacted. Now we need to determine the grams of aspirin by doing a mole conversion. Simply take the moles of aspirin reacted determined in the last step and multiply by the molar mass of aspirin. Finally, to determine the percent of aspirin in a sample, take the grams of aspirin calculated in the last step and divide by the total grams of tablet weighed out in the lab. Multiply by 100 and we get the weight percent. So in each tablet there is 21.69% aspirin.
Gloria, the lab was a real success.
That's great. Show me your results.
Okay.
Well, in the determination of our unknown sample, our mass of our tablet that we were setting was 0.3405 grams.
And the mass of aspirin determined was 0.0739 grams.
This gave us a weight percent of 21.69%, right around the 22% you were looking for.
Oh, thanks, guys. This would not be possible without your hard work and diligence.
Aw, thank you, Gloria. Well, Jill, it feels good to solve mysteries.
You know I wouldn't have it any other way.